Hello, everyone, and welcome to our February LocalStack Community Meetup. I am very glad that you all chose to be with us. You could have chosen to be anywhere else in the world, but you're here with us. Whether this is your first meetup or you've been rocking with us for a while, you know this is a space where we keep things practical, we keep them real, and we keep them developer focused. Today, we're digging into a topic that shows up fast once systems get complex, and that is modeling real world relationships in our data and how to actually build and test knowledge graphs without slowing down your dev loop. Okay, so a quick rundown about how things are going to flow today. First, we're going to hear from Joshua Sen from TypeDB about why property graphs aren't enough. Then we're going to do a short Q&A with him. And then our very own Harsh Mishra will teach us how to build knowledge graph apps with LocalStack and TypeDB. And then we are going to wrap up with a quick Q&A for Harsh. We've also got great speakers joining us. Of course, we've got Joshua Sim from TypeDB. Joshua has been part of the TypeDB journey for about 7 years and led TypeDB 3 rewrite in Rust, which is like one of the most popular programming languages today. So awesome. Today he's focused on improving accessibility, developer experience, and ecosystem integrations for TypeDB. Welcome, Josh. Why don't you give the community a little bit of an intro and just a tiny bit of lore or a background or something for us to kind of chew on while we prepare for your presentation.
Yeah, sure. Thank you so much. Hi, everybody. I'm Josh. I am the CTO at TypeDB. I've been at the company since 2018, I would say, 18, 19, something like that. And have now kind of taken on the mantle of technical leadership. And as was said, I had the last big project of rewriting TypeDB 2 into 3 for Rust. And that was largely for performance and for stability and because we love Rust, but that's not a great reason. So mostly for performance and architectural changes. And so I'll show you a slide on performance a bit later. But yeah, I'm based in New York. The team is in London. So we are kind of covering both of those fronts. So if you ever want to talk to any one of us, we're available in both time zones. And we have a very active Discord community with thousands of people in it. So come hang out there. And yeah, we're friendly. We don't bite. So come hang.
Awesome. Thank you so much for joining us. And we are also joined by a very familiar face, Harsh Mishra, a fellow DevRel engineer here at LocalStack and AWS community builder. Harsh's work centers around DevOps, platform engineering, CI/CD, and the like. And he's been helping to drive some exciting integrations across the LocalStack ecosystem, including getting us in the AI game. So thank you, Harsh, for being here. Can you give us a little bit of info about what you've been working on lately, who you are for folks who don't know you, and just kind of, something for us to noodle over?
Definitely. I guess I have given a few talks already with the LocalStack meetup, but some of the older faces might remember that I have been at your place, Kaya, mostly hosting these meetups around here. So it's always a great scene to kind of be on the other side. And yes, lately my focus has been mostly around extensions, integrations, and that's how we got to collaborate with some great developer tools out in the ecosystem like TypeDB and others. And I'm just so excited to be showcasing the TypeDB extension for LocalStack. So for people who don't know about TypeDB, I guess definitely stay on to learn more about it from the man himself, Joshua. And if you want to see how it integrates with the LocalStack ecosystem, you can wait for the next 30 minutes for my talk. So over to you, Kaya.
Oh.
Kaya, I guess you're muted.
I don't know how I got muted. Sorry. All right. Very excited about this meetup. It's going to be a good one. Happy to have you both here. Sit back, relax, and learn something. Joshua, the stage is yours.
All right, thank you. Just give it a sec for my slides to come up. Okay, so basically, I'm here to talk to you about a aspect of TypeDB that people come to us a lot for, which is the graph modeling capability for knowledge graphs, for data storage that has graphy network-like properties. So yeah, and the reason you would use TypeDB over something like the popular Neo4j or other labeled property graphs, that's kind of ground I'm going to cover today. And so aptly, the title is Why Property Graphs Aren't Enough. And we'll start with just kind of some high level stuff, and then we'll go to a little example, and then I have a little demo where we can play around with our studio UI, and you guys can even throw some questions in the chat and I can try things live, assuming we get to that. So anyways, starting over here, what do graphs solve, right? Why do people pick up graph databases over the relational databases that have been industry standard for 40 years or something? And a lot of that is really coming down to complexity of data sets that people have these days, the fact that data has become much more complicated, interrelated, and in my opinion, relationship centric. So when people talk about graph databases, they're really thinking about the nodes and edges, where the edges comprise of how these things are related to each other. And so binary graphs, labeled property graphs, let you really visualize and build network data sets effectively and intuitively. And so I think the part of the evolution of a graph database is so that you think in graphs rather than tables, and tables with joins, and so many different layers of complexity you have to get to understand your data. And there's another flip side of graphs, which I think they are really good for, which is graph analytics. So if you're doing stuff like shortest path, if you're doing stuff like clustering or community detection, you definitely want a graph database. And I'm definitely going to support anyone that wants to do those problems and tell them to use a graph database. But some of these other topics, such as relationship centricness and the connectivity of data sets, I'm going to argue is that graph databases, in particular, the incumbents like Neo4j and CosmosDB that are simple labeled property graphs, so nodes, edges between nodes, and labels on both of those, aren't going to be enough for you to actually tackle graph-shaped data and handle things like knowledge graphs, which by word of knowledge are including a lot more complexity than simple graphs. So we'll go from there. And what we find is that the reality of graph databases tends to be quite messy. And so you have a very simple data set and a simple data model. First of all, you could do it in relational, even if it's graph shaped. But really, graphs are too flexible, so flexible that you end up making a mess. And you end up having to enforce the structure of your graph data set in your application. And that's due to a couple of things, but labeled property graphs are not designed for structure. And that basically means that you don't actually get help when you start to try to tackle complexity in your data sets. And that is something we've seen time and time again in people building knowledge graphs in finance, knowledge graphs in logistics and supply chains and cybersecurity. And that really, it looks good at first. And then once you start hitting the problems of graph databases, like the fact that an edge can only go from one node to another, that you start to have to put hacks in, you lose the structure of your system integrity, and that leads to a big mess. So I had Gemini generate a little graph, which I thought was quite fun. But that's kind of the reality of building real graph systems. So they built up some momentum. I think that's legitimate, but I think we can do a lot better than that, and that's why we're here. So just to hone in on one particular limitation of labeled property graphs, and I realize I've written that wrong, LGP, that's my bad. But one of the fundamental things you run into with a regular graph is that you can't store relationships, edges, between more than two nodes without resorting to hacks. So we have a demo data set called Bookstore, which is kind of like a e-commerce type of setting. And so in a normal example where you just have books that are published by a publisher, which I've written here in Cypher, which is the labeled property graph kind of accepted language these days, which is Cypher from Neo4j originally, is that you have a node publisher and you have a node book, and then you have this little visual representation of an edge with a little arrow with the label in the middle called publishing, and that's how you do a simple connection from one node to another. Now, this works fine for books and publishers, but what if there's another piece of written content that a shop wants to sell, which is a magazine, and you want to say this magazine is published as part of a collection. So that's like we have an issue for January being published by a publisher as part of a magazine collection. And fundamentally, you have to now make a choice in a simple binary graph is I can't do a three-way edge. You can't say this is published atomically as part of a collection, a magazine, and a publisher and an issue. So there's a piece of information here that really has to fundamentally represent that fact, but you can't really do it. So you have hacks, and the hacks are all not great. You can have multiple relations, but you lose the property that they're intrinsically linked. You have, you could just add properties on your relation, but that is not as meaningful as an actual three-way edge. Or you can do the hack that is the recommended hack, which is called reification, and you turn your publishing edge into a node. And now if you're trying to build this model and support both books and magazine issues, now you have sometimes your publishing is represented by an edge, and sometimes for magazines and issues, it's represented by a node. And that just is so messy that you have to start really then building abstractions over your graph database in the application, which is just even more mess compounding on mess. And fundamentally, what you're running into here is a limitation of the model, a limitation of the expressivity and the features that you get from a simple property graph. So that's when funny enough, I'm going to come in with TypeDB. And one of the key things that makes TypeDB a generalization and also a more powerful version of graphs is that you automatically get what we call n-ary or n-way edges. So edges that can have more than two components in them. And in the previous example, in our query language, if you want to just say that books are published by a publisher, you would say that we're variabilized query language. So you have a publisher variable and you have a book variable, and you just say there's a publishing relation between a publisher and a published book. And then now if you want to extend this to 3, it's very easy. You just say, now I have a publisher, a magazine collection, and an issue of the magazine, and you just say it's a publishing between all 3. And so you don't have to make a trade-off here. Am I going to have 2 relations, which you can still do if you really want to? You have full flexibility. You can have labels. We have a way to do that too, called attributes. You can still do that, but you actually get what would be the quote correct model given to you, where you can have 3 components in one edge at the same time. So that's what we call n-ary edges. And there's no reason at all to stop at 3. You can have 4, 5, 6, and essentially unlimited number of components in a relationship. Another common use case for this is if you want to highlight an entire subgraph of your bigger graph, is you can make a relationship that just connects to everything at once. And then you can treat that one relationship as an abstraction over a bunch of nodes in your graph. And that's not something you can do in a labeled property graph. So immediately you see that we're relieving one of the key bottlenecks that people run into in using something like Neo4j for real world data sets. So what do we do in TypeDB? Well, we've taken some of the best ideas from graph and some of the best ideas from really relational and programming languages. As I've said, we love Rust. There's some inspiration there as well. And you get the full modeling flexibility of a graph-shaped structure where we don't restrict you to 2-way edges, but you can have 3-way edges or 5-way edges. And you can even do edges onto edges. So you can say there's a relationship connecting to a relationship. Let's say you want to annotate a particular relationship or edge between things with more metadata, and that's a very common way to put relations on relations. We also ship with a schema, and part of that is to tackle what I mentioned about complexity. So our schema gives you essentially a structure to write what your data should be shaped like. And then the system will validate it for you. So in property graphs, it's so flexible, you can throw anything in, but then anything's in there and you have to do that enforcement somewhere else. So we give you the tools, if you want to use them, to validate the data in the database directly. And then lastly, as part of our data model, we have stuff like subtyping and inheritance built in. And that basically lets you deal with the key problem of one of the reasons people come to graph is for complexity of their data set, for kind of graph shapedness of their data sets, and the interrelationships and the bushiness and the connectivity. And we give you the tools there to build simplification the same way you would build it in a programming application language setting, where you build layers of abstraction, and we give you the tools for that as well. So I just wanted to run through an example quickly, but fundamentally, we are providing an abstraction system that is super flexible for graphs and also will give you data safety on the fly, validated by the system. And you also keep a lot of the properties that you get from graphs, which is an easier query language, no having to think about joins, and high performance. And I'll show you the performance numbers toward the end as well, because that's a recurrent question when we present on this. So quick example, building a bookstore. This is going to be a different example from what the LocalStack team is going to present later. So you get to see two different environments where TypeDB is being used. So just to run on the bookstore example here, we have books and issues that are published by publishers. You have issues that can be published as part of a magazine in a three-way relation. So I wanted to illustrate that. And then also, let's say we wanted to track sales data about particular publishings that have happened on online sales and physical sales. So this is a little snippet of a schema you would write for modeling that. This is a step you skip with graph. So you just throw your data in and then there is no real schema. For us, you define what it looks like first, and then you add your data. And this is where the properties of enforcement come from and abstraction come from, as we'll see in a second. But you could just start with this simple model. You have entity book, which have a title, and an issue that has a title. And there's an attribute there which holds the actual value of the title. And so that's a perfectly valid data model in TypeDB. Super easy, very intuitive, very close to natural language, easy for people to understand. And then we can start to evolve it. So the first thing we can do is notice there's duplication. And when I identify this, this is, for instance, a common pattern of complexity that arises in graph databases, especially because you just start duplicating patterns across your data. It's basically like if you're writing code and you just copy paste a bunch of duplicate stuff all over the place. Really, you want to kind of abstract and bundle that away if you can. So for us, we have this idea of subtyping, where you can introduce a common parent, a common thing that you inherit from when you have shared behaviors. So you can define a piece of writing which owns a title, and you just make two subtypes of it. You have a book and an issue, which are both types of writing. And again, we really encourage people to model with natural language, which is another big important way to handle complexity. It's about establishing a vocabulary that is familiar to you as the developer and the business side of your company and the application. And it's kind of like a domain-driven approach to thinking about things, which we find works really wonderfully for our data model. And so what we can do with that is, once you have some data, is you can start to retrieve all books and issues at once by looking at all writings. And that's just part of the way the system works, by analyzing what you've written in your schema, what you've written in your query, and then figuring out all the applicable components and retrieving it for you. So this is one way, like I was saying, of handling complexity as it arises, is you build these abstractions over really sophisticated pieces of detail, and then you don't have to worry about it. You can evolve it later and everything will work. You could add a new subtype of writing later, and this query you've written about looking at all types of writing will immediately work without changing application, which is super neat and powerful. So we've got books and issues in our database that we can model. And we now want to model binary and show some three-way relations. So let's introduce the idea of a magazine, which will be our collection of issues. And let's start with a simple publishing. A simple publishing is just going to relate a publisher and a published item. And basically, this is a definition of a relation. Very first class, super easy to understand, just has two what we call roles. So instead of a directional edge, because we have to generalize to also many directions, not just a to and from, is you have to name your roles or components of your relation to know which direction and point of the relation you're looking at. And then we can apply the subtyping trick again to say, particularly, we want magazine publishing to also have a publisher and a published component, but we also want to relate a collection. So now we have three components in this magazine publishing relation. And then at the bottom, we basically tell the system, I want my writing entity to play this component, which is the published. So any type of writing will be able to be a published item. And a publisher will be able to be a publisher in the relation. And then this magazine entity will be able to be this new third component, which is a collection in the magazine publishing. And so now we basically can immediately see that we'll be able to create data where you have a piece of writing, a publisher, and a magazine all at once. And even further, just to give you the power of real advanced relationships and general flexible relationships that we have, is you can attach relationships onto relationships. And so let's say we want to build some sales data annotations over publishing events, publishing like the fact that something was published. We can make a sales data collection relation, which points to a publishing and some data. And then we basically say, now we have this kind of complicated, potentially three-way publishing relation that can also be pointed at by a data collection event, essentially, to some actual sales data, which will record the online sales and the physical sales. So fundamentally, we're building like almost like a metadata abstraction over the fundamental data, which is simple books, publishings, and add a layer of annotations saying, here's the data about the things we've collected. And you could keep going. You could say, and about those data, here's the analytics that have happened, or the collection sources, or you see this a lot in building aggregate knowledge graphs, is you annotate the data source and the date, and then you can say this evolved, the metadata evolved to a new metadata over time. So you get so much flexibility and power from the ability to put relations on relations as well. And again, this is not something you can do at all in a property graph. Just a little example of a little data set, but we have basically a publisher, a magazine collection, a book, 2 issues, and a bunch of relations between them. And this is what our query language looks like to insert data. And the reading of data looks almost the same. And I'm going to zip over that so we can get to the interactive part as well. Great. So how does it look to retrieve data? Well, I wanted to just highlight a couple of things. This is a structurally matching query. It's basically the system will be able to understand you're looking for all kinds of writing, because this is the variable here, and any kind of publisher, and you're just going to fetch all the attributes stored on those. And this is going to say, oh, okay, I know that publishers must be a type of publisher, and writings can be issues or books. So let me get all of those as a collection at once and then give them to you without having to specify I'm looking for issues and books separately, or even to say what type of writing I'm looking for as a writing itself. And we call this a type of polymorphism, where the system can work out what type of data you're looking for because you've written the structure in the schema. Also to show you what kind of hopping through relationships looks like in TypeQL. So in Cypher and Neo4j, you have this kind of arrow syntax. And for us, you use this bracket syntax. So you say that I'm looking for a book that is a publishing. Here's a relation. And then we can point to the publishing relation itself. And I want to look at collected data, another variable over here, and then pull out the online sales data from that particular sales data object. So you're saying I am going from a book to a relation on that relation to a piece of data, to the online sales attribute. And that's kind of this. You can just keep building these. You can build tree structures, diamond structures, whatever you want, just by manipulating how these variables are connected in your query. And so that's how you get around the kind of visual arrow syntax, because obviously an arrow can only go from A to B. It doesn't really extend to multi-way relations. Right, so one of the benefits, putting that aside a little bit, but one of the benefits of having structure that something like a labeled property graph doesn't get you, and I think this is particularly appealing to people who think about testability, correctness, security, all of those things, which is exactly the stuff that LocalStack thinks about, is that our system, because you provided structure to the system, you can build, I realize I've changed the query when I actually submitted it, but essentially it was the same query. You can catch errors early. And what I say by that is, because you provided the data model in the schema to the database, it'll warn you when you've done the wrong thing. So if you accidentally flip your arrow the wrong way around in Neo4j, that'll just run. It'll just give you no answers. But for us, because we explicitly said that a book must be a published item and the publisher must be the publisher, if you flip it around, as I've done here, the system will warn you saying, there's some error here happening, I can't figure out what you want, and therefore this is an invalid query. This is not a permitted valid thing. And it's exactly like getting a compile error in a programming language. So you can see kind of where the inspirations are coming from. It's coming from SQL, from programming languages, and from Graph, bringing all the best ideas together. Another cool thing you get from having a high-level language that's pretty Englishy, and also having a schema that describes the structure of your data, and we can play with this a little bit later, is that you get really good AI-generated queries. And this is just something we've launched in our studio, online web studio, which I'll show after this. But you can basically use natural language to generate queries on the fly and then interact with a database like that. And so that works really well, primarily because we've given structure. And if you try to do this in Neo4j, you get a certain percentage of hallucinated connection types or messed up directions and stuff. And that's just because the structure doesn't exist fundamentally. And as long as labeled property graphs are loosely typed, loosely coupled structures, this will always persist. And this is probably where even an older relational database would have an advantage. And yeah, this is the question we always get immediately, is performance. So we are early in our TypeDB 3 evolution and learning. So we are still in the process of optimizing. This is also an older chart from halfway through last year, I think. But basically, Neo4j, I've heard personally from many people who have come to us from Neo4j, but also in our own testing, has a real cliff after you leave the data set, after the data set leaves what fits in memory. And as we can see here, Neo4j is quite fast as long as you have enough memory. But right here, where around 100, sorry, this graph is a little bit unannotated, but the scale is essentially gigabytes. And the y-axis is transactions per 10 minutes, essentially. And in a mixed workload in a well-known TPCC benchmark. And so, which is a transactional processing benchmark modeling kind of e-commerce orders coming in and out of warehouses. And so it's just a classic thing of like their data model works really well in memory. And then as soon as it goes beyond memory, the way they've structured their system doesn't scale that well. And yeah, that is also something they've kind of baked into their model. All right, so basically, what is TypeDB? It's what we call a hypergraph. So this generalization of binary labeled property graph models, where you can now have n-way edges or relations connected to relations. That's called a hypergraph. And it's not a term that many people are familiar with, so I don't want to introduce it from the get-go. But what we do is we implement a hypergraph natively, and we give you what we call an entity relation type system to build your schema. And it's big words, big vocabularies, but essentially it's just a nice way to describe your data, build abstractions with things like subtyping and role-based composition in relations, And what you get from that is a really nice, simple language that lets you catch errors early and write really expressive queries to pull out data on the fly really neatly. And there's a whole side of this where you can actually modularize further with functions, just like in a programming language that I haven't even talked about. And that's maybe for another day. Great. So as I said earlier, we have our website, but we're very active on Discord. Come join the community. We have, I don't know, some thousands of people in there who lurk and who chat, and we're open source. So we have a core edition that is available in various formats, such as Docker, and it's on GitHub. And then we have a cloud and enterprise version for the people that need production ready big system stuff. But yeah, come talk to us if that's interesting. And I will hop over to a quick demo if I have a minute. And I just wanted to show our studio where I have preloaded this test where I can basically ask, I could write queries, and I can have this agent mode to ask some questions. So write me an interesting query, and then this will go away and come up with some interesting query to run against the database. Wow, it's come up with a very interesting query. Right, so, and then here it's got a syntax error somewhere, so we can just ask it to fix it itself. But basically, you can iterate here as you would with any agentic system. You can look at the schema we've created. So you have pieces of writing with two subtypes, books and issues, that are participating in a publishing type relation with a specific type here, subtype called magazine publishing. And I'm sorry if this is going quite fast. I'm happy to chat with anyone afterward, and we can explore the data. And there's a nice way to look at your data set and traverse through it. All right, sorry, so that was a bit of a whirlwind tour of TypeDB. I'm super happy to answer any questions. I feel like there are some comments that have popped up. So yeah.
Yes.
Great.
Thank you so much, Joshua, for that marvelous presentation. Yes, we do have quite a few comments. Thank you, folks, for interacting in the comments here. So VP at Strato.space seems to be very impressed. He shared a few comments. And yeah, so he's got like a couple of pretty real interesting comments that he's shared. And also, Runfish seems like he asked a question. Thank you for one, your comments, VP at Strato.space, and number two, Runfish, for your question. A book cannot publish a publisher. Normal DBs don't warn you out of the box.
Yeah, so that's exactly what I was showing. Our system can tell you when that's an error because you've told it which direction the publisher has to be pointing, and to what. And if you do that in any other system, even relational databases, you can join two tables in the wrong way that are not meant to be joined. You get no error. It just gives you nothing, no answers. So we love this distinction that new languages like Rust have done, where there's a difference between essentially no results and an error, and we don't conflate those things.
Very good. Very awesome. Also, there are a couple of additional questions that we have. So what languages do your drivers support?
Yeah, great question. So we have native gRPC high performance drivers in Rust, Python, Java, coming up C# and C. And then for the rest, we have an HTTP API as well that comes with a pre-bundled TypeScript one as an abstraction layer over it. So, or you can build your own over HTTP in any language.
Oh, that's awesome. Okay. Well, how about, Don, actually, I know that you mentioned that you all have an open source offering. Is that like, is everything TypeDB open source, or is there like
Great question. Yeah. So everything you need to build a real product is an open source. I think the line we would say is if you need something like high availability in a cluster, or if you need audit logging, or if you need role-based access control, these things that are slightly more enterprisey, or things people need for user-facing applications, then you go to our cloud, and that's a paid feature. So that's basically where we draw the boundary. But for many internal tools or for researchers and prototyping especially, the community edition does everything you probably need.
Awesome. That's very good to know.
Is ontology always hierarchical? Hi, good question. So you can build your model flat as much as you want, and you can just compose everything with relations. The abstraction we support are essentially the relation roles, which you can attach to anything in your system. So entities and relations can be connected by our roles. So that's kind of like traits in Rust or interfaces in Java. But then, yeah, you can build single inheritance, so single super type inheritance in your system if you want. And the cool thing with TypeDB is you can granularly swing how much you want to build into your type system, or do at runtime with fewer types and just make a general vertex and edge type. And you basically get exactly the labeled property graph model out with minimal effort.
Very good. Okay, so we got one more question.
Uh-huh.
If someone wants to experiment with this weekend, and I know this is something that everybody is thinking about, like what's the fastest path to get real value?
So quickest thing you can do is go on our website, start building, go to the cloud, spin up a free cluster. That should be like 5 minutes. You get a free instance in the cloud from on us, and then connect with Studio, which is the interface I told you about. When you're spinning up the cluster, we have some pre-made data sets. Spin one of those up with your database that we give you. And then you can directly, if you don't want to learn the language, use the chat mode, the agent chat, to generate queries and see what that looks like. And if you want to start manipulating the database, start writing queries and have a look in our docs for that. But the agent mode is a great way to learn.
Very good. Well, thank you so much, Joshua, for your presentation and answering these questions. Definitely, you know what? I would like to plug your Discord, so we will plug it towards the end. Thank you for coming through.
Thank you. Appreciate it very much.
With your knowledge. So yeah, let's move on to our very own Harsh, who's going to talk to us about the integration between LocalStack and TypeDB. The stage is yours, Harsh.
Thank you, Kaya. Thanks a lot for the introduction and for everyone who has joined us today to be a part of this meetup. So in this particular talk, I'm just going to walk you through something that I'm really excited about. And we are going to be talking about building knowledge graph applications with LocalStack and TypeDB. So in this session, we will cover what TypeDB is, but I guess Joshua has done a pretty comprehensive introduction already. So I won't go much into that, but I'm going to be showing you how TypeDB integrates with LocalStack. And I'm also going to be showing you a live demo of a sample app that the TypeDB team has put together that showcases how you can use both LocalStack and TypeDB together to build your applications like locally. And by the end of this talk, I'm pretty sure like you will have a clear picture of how TypeDB and LocalStack basically fit together and how you can start using this in your own projects and how you can also take it for a local run instead of doing everything directly on the cloud. So moving over to the next slide. And before we dive into TypeDB, I just want to give a quick refresher for anyone who might be new here, like what exactly is LocalStack? So LocalStack is basically an end-to-end local cloud development platform for building your cloud data and AI applications. Our focus has been so far been on emulators, basically giving you a way to speed up your inner development loop. So if you have got an AWS application that uses a bunch of AWS resources like Lambda, API Gateway, Elasticache, SQS, SNS, and more of these. So instead of deploying it to AWS every time you want to test something, you can just run all of that locally on your machine. You don't need an AWS account. You don't have to spend anything on the real cloud, and you basically get instant feedback through whatever development you're doing right now. And our journey has been pretty much expanding into this whole full platform structure where we also support the outer development loop. So things like sharing, integrating, reviewing, and testing your cloud applications. And what we're just going to talk about today is a really good example of how we are expanding that local development experience that goes beyond just AWS services. So I'm pretty sure some of you might have seen this meme or this version of the meme floating around in different formats. And I guess you will be able to get the kind of pain points a lot of developers suffer today. But like, here's the thing, like a lot of applications, especially like data applications out there, need to model like really complex data relationships. And when I say complex, I mean stuff like knowledge graphs or access control systems or org hierarchies, multi-way relationships. That is actually very difficult to kind of get through. Like, for example, let us say in knowledge graphs, you have got nested hierarchies, you have got things that are pointing to other things that are like things that are multiple levels deep out there. If I talk about access control systems, for example, the permissions are pretty much transitive. Like, for example, if you are a member of a team and that team is part of the department and the department is part of the company, you should basically inherit access from all the three levels. If I talk about org hierarchies, groups can contain other groups, and you need to figure out who has access to what across all those different nested layers. Now, take this thing. If you try to model this kind of a stuff in a traditional SQL database, you know that it would get painful pretty quickly. You have to like do multiple round trips to the database. You have to like push like a bunch of traversal logic into your application code. As Joshua mentioned previously, like graph databases like Neo4j, they definitely help. But they often lack schema enforcement, so you lose that safety net of knowing whether your data is structured correctly or not. And I guess this is where TypeDB basically shines and comes in. And as Joshua mentioned, it's an open source polymorphic database. And instead of organizing your data as rows in tables like SQL or as nodes and edges in a graph database, TypeDB, at least to me, organizes data as entities, relations, and attributes. So if you have done any sort of object-oriented programming, like you must have studied that in your college or in one of your first jobs out there. So if you have done any object-oriented programming, you will know that this feels very familiar because it's technically using the same concepts. You define the schema using TypeQL, which is TypeDB's query language, and all your data has to basically conform to that particular schema. So it's like how objects in code have to match their class definitions. The strict typing catches your errors pretty early and makes your query predictable. Uh, so TypeDB already supports like a bunch of things. It supports inheritance, polymorphism, first-class relations, all the fundamental concepts that we inherit from object-oriented programming. It has also got a pretty exciting thing called as TypeDB Studio that Joshua kind of showed us around. So you can see your entities, relations, attributes like listed out there, and you can see like a pretty nice visual graph of how all of these different things connect. So the bottom line is, if your application needs to deal with knowledge graphs, access controls, or org hierarchies, TypeDB is like a really natural fit for your applications right there. So this is where things get pretty exciting, and this is what we are introducing today. We have built a TypeDB extension for LocalStack. So if you're using LocalStack today, you can technically start using TypeDB within your local development workflows without having to configure anything else. So you can basically like run a fully functional TypeDB server right inside your LocalStack environment. And with LocalStack, you get access to creating like multiple AWS resources locally. So you can like also run TypeDB alongside those other AWS resources. You don't have to set it up separately on cloud. You don't have to do a separate Docker Compose setup. You just install the extension once, and TypeDB is available whenever LocalStack is running. So the good thing with this is like you just like need one command to install this, and you're done. You don't have to set up any extra containers or configurations. So every time you start up LocalStack on your machine, TypeDB would automatically come up. Now, I don't want to take the merits of the hosted version of TypeDB away. It has some great benefits out there. The area where the TypeDB extension is really valuable is that it's really, really good for testing. So every time you restart LocalStack, you get a fresh, clean TypeDB instance. So you can always like run your tests against a fresh database every other time. Plus, on top of that, you don't have to provision any external infrastructure, at least for your dev and test phase, and everything basically lives on your machine. So this is how it looks like on the LocalStack web application. You can just go ahead, create a free account, and you will be able to get access to this extensions library that I'm just going to show you as part of the demo. And you can just take it for a run using a free license altogether. So how it works under the hood is pretty straightforward. We are using the TypeDB Docker image to start up a container. So when you start LocalStack with the TypeDB extension installed, we will start up the TypeDB server inside the LocalStack container. Now, the benefits of using an extension is that LocalStack actually provides a lot of primitives, a lot of constructs that allows other emulators or Docker containers to kind of share the same network, the same life cycle. So when LocalStack technically starts, TypeDB also starts. When LocalStack stops, TypeDB will stop. And your application can connect to TypeDB through the LocalStack gateway. We provision a special gateway at typedb.localhost.localstack.cloud. So you don't have to set up any special local only configuration. You don't have to change any part of your code. You just point to this local endpoint when TypeDB is running on your machine, and everything just technically works. And this also means you get the same hostname locally and in CI. So if you're running tests against your TypeDB apps, you can pretty much set up a CI/CD pipeline. You can use LocalStack to spin up the TypeDB server alongside your other AWS infrastructure, and TypeDB connection works exactly the same way. So to get started with the TypeDB extension, you can just use this one single command, LocalStack extensions install. You just need to install the LocalStack CLI. You will be able to figure that out on the LocalStack docs. We will have a link on the chat. And you can install the LocalStack CLI. You can get a free authentication token. That would basically allow you to install the TypeDB extension. So once TypeDB extension is installed, TypeDB would be available at typedb.localhost.localstack.cloud every time you will start up LocalStack. And that's pretty much it. You don't need to install TypeDB separately. You don't need to configure any Docker networking. It's all handled by the extension. So enough of this. Maybe now is a good time to show you the quick start around how you can set this up. So what I'm going to do here is I'm going to start sharing my cursor. And I've got this nice visual web experience already over here. So assuming that you already have created a LocalStack account, if not, you can just go to app.localstack.cloud. And if you're new there, it will prompt you to create an account over there. It literally takes about a few minutes, give or take, to actually get this done. So maybe I should just minimize this experience a bit to make it clearer. And we have got this extensions library that would be available to you. And this is where we have got multiple extensions that are available for you to install on your local machine. So we have extensions like FireMock, MiniFlare, Resource Graph, Mailhog, HTTP bin, even emulators for Stripe and Authors out there. So, and we are always going to expand this extensions library further. So if you've got any fresh ideas about extensions that we can build on the LocalStack container lifecycle, we are all ears. You can always join our Slack community and let us know about what extensions you would like to build or you would like us to build out there. So we are all looking for feedback on that front. But this is where the TypeDB extension is available. And you just need to click on install on instance, and you need to choose the default instance. And over here, I just need to start my LocalStack container once. So to install the LocalStack container, all it takes is running this command called as LocalStack start. So once you run this command, it is going to pull the official LocalStack Docker image, and this is going to start up the LocalStack emulator. If you don't have the extension installed already, it is just going to start up the default Docker image, which is going to be comprising of over 100 AWS services at this particular moment. But if you've got extensions installed or you install Flex extensions, it's going to be available right here. So my LocalStack container is up and ready. And as you can see over here, my TypeDB extension is already installed. But if it is not installed, you just have to click this install button. And this is going to install the extension. This is going to restart LocalStack for you to give you a fresh ephemeral instance. And you can always get started to start working on this. So this is how easy it is. It literally takes 3 steps. Get your free LocalStack account, install the LocalStack CLI, start the LocalStack, and just go ahead and install the TypeDB extension through the LocalStack web application or through the CLI command that I showed you on the slide deck. And once you have that, the TypeDB extension would be available to you. You can connect. So if you have got any TypeDB code already that you want to run against LocalStack, you can just connect to typedb.localhost.localstack.cloud. And you should be able to just start running your queries and doing all sort of experimentations, development, testing to just get it up and running. So just going back to the slide deck now, I can just put it back on the stage. Yes. What I'm going to show you as part of the demo today is that we are going to build a knowledge graph application. And this is going to be like a simple user and group management service. It like really showcases what TypeDB can do with AWS services on LocalStack. So as you can see in the architecture over here, we have got a user that connects to API Gateway, to Lambda, and then to the TypeDB. So what API Gateway does is like it exposes the REST endpoints for creating the users, for creating the groups and querying the memberships. The Lambda function over here handles all sort of business logic. So they receive the API request and they query the TypeDB for membership hierarchies. And the TypeDB basically handles the data model. So it stores the users, it stores the groups, membership relations, and resolves transitive group membership through those recursive functions that we're going to see next. So the whole thing is deployed with Terraform to LocalStack. So you don't have to like just do it separately. If you have got any infrastructure as code like Terraform or CDK, you can just technically use it with LocalStack. And we also provide you a web UI that I'm going to just show you that will give you a nice visual representation of the data. Again, everything runs locally. You don't need any sort of an AWS account. The source code for this demo is also open source. So I'll just drop the link once I'm done with the demo so that you can also take it for a run and try it out. So with that said, let me switch to my demo screen now, and let's go full screen to make sure that everything is visible in this case. Awesome. So as I said already, my TypeDB extension is installed. And what I need to do next is to actually install the dependencies for this project. We provide you pretty handy makefile targets over here that allows you to automate like a bunch of these things. So we have got a target for installing all the dependencies. So all I need to do is make install. And this project is actually using Python over here. So you just like need to have Python on your machine and everything should run end to end without much problems. So as it is being installed, let me just quickly walk you through the project structure that we are going to deploy. So first, we have got this app directory, and we have got the Lambda subdirectory, which contains the Lambda function code. This is what the Lambda function code basically looks like. And then we have got the TypeDB schema definition in the schema.tql. So this is where we define all the entities, users, groups, and everything around here. That's like going to basically store our data relationships in this case. And there's also like a TypeDB HTTP driver, which is like the HTTP client for communicating with TypeDB. Plus, on top of that, as I said, we have a web UI in this case. So it's pretty much like simple HTML, CSS, JavaScript frontend. And at the root, we have got a main.tf file that is going to provision all the infrastructure for us. So the API gateway, Lambdas, the IAM policies, IAM roles, and everything that is going to ensure that we can set this application up in a proper fashion. So LocalStack provides you a very handy way of installing, of setting up Terraform on your local machine. So we have got this integration called as tflocal that I can show you over here. So this is tflocal. This is as part of our integration with different infrastructure as code frameworks out there. And you just like need to set this tflocal script up. If you are using CDK or SAM or any other AWS infrastructure as code framework, you can technically use that up. And what tflocal basically does is like it redirects all of those AWS API calls, and instead of letting them go to the real AWS cloud, it will send that to the LocalStack container. So you can set everything up on your local machine without having like much issues. So tflocal is like it's wrapping up the Terraform CLI itself. So you won't basically see any difference between tflocal and Terraform. The only difference is that it's going to reroute those AWS API calls that the Terraform CLI was going to make and send them back to the LocalStack that's running on your machine. So since I have already showed you how this is going to work, I just like need to use the makefile target that's going to set up Terraform on my machine. And in this case, the makefile target is going to be tfdeploy. So I can go ahead, I can say make tfdeploy. And as you can see, I'm just like preparing my Lambda to be deployed. So setting up a function zip archive. And I just use tflocal to initialize my Terraform config. And I just apply that config back to my LocalStack container. So if I actually show you the LocalStack container over here, you can actually see like those AWS API logs popping up slowly, showing you all of those different API requests that Terraform technically makes to AWS. but we have managed to trick it to make them against the local stack container. So I guess this is actually deployed. This is cool. If you try to set this up, let's say on the real AWS cloud, it's going to really take about 4 or 5 minutes at the very least. But with local stack, it's like really blazing fast. It just takes a snap of a finger and you have your AWS infrastructure set up really fast on your local machine out there. So what we have technically done is Terraform has already created all our resources. You can actually see the outputs in this case. We have got API endpoint. We have got all the different outputs like the groups endpoint, the members endpoint, and all of these different things. So now that our application is actually set up, you can start verifying whether your data models are actually working or not. So the first thing that you can actually do over here is, let us say you want to run the integration test suite. You can just say like make test deploy. Okay, maybe I'm using the wrong target. So make test lambda. And as you can see, I'm using PyTest over here to like run automated integration test suite. And what this is doing in the background is like it's connecting to the API gateway. It is starting up those lambdas. The lambda is connecting to my TypeDB database. And this is where all the queries are actually being run. You can verify that in the local stack logs. And if I show you my Docker containers running at this moment, you would definitely see like TypeDB to be one of those containers that are actually operational right now. So this is how it works. Plus, on top of that, if you're using the local stack web application, you also have a very nice visual layer of interacting with your resources. So if I go to the local stack web app, you can actually see all of the resources that we just deployed right now. So we set up a Lambda called as user service. We set up an API gateway called as users API. You can go to the status, click on Lambda, click on the Lambda details over here, and you can basically get to see everything right in this case. So before I try to show you the web UI, I really want to show you, I really want to help you understand the schema over here. So the schema is basically the heart of the whole application. So if I actually go ahead and let's say open up the schema.tql file, so at the top, you basically see that we have got a principal defined as an abstract entity. So you can always think of it like an abstract class in Java or Python. So both users, both user over here and the group over here, what they are basically doing is like they're inheriting from the principal. So this means that anywhere TypeDB expects a principal, it can either accept a user or a group. This is the most fundamental example of polymorphism at work. Then we have got the membership relation. And as you can see, like this contains a container, which is practically a group. And it contains a member, which can be a user, or it can be another group altogether. Now, since groups are also principals, a group can be a member of another group. So that's how we particularly get nested hierarchies. And the place where it gets really, really powerful, and perhaps my most favorite part of TypeDB, is the recursive functions. So we have got the group members function, which basically returns all the members of a group, including members of the nested subgroups. So the get group will return all the groups that a user practically belongs to, including those indirect memberships. And these functions basically recurse through the membership graph, and TypeDB will evaluate them at the query time. Now, the reason why I like this so much is because you don't have to create any loops in your application code. You don't have to do like any database round trip. You just have to like put in one query, and TypeDB will practically handle all the recursion for you out there. So with that said, it's actually time to get this up and running. I have some sample commands over here that kind of shows this in practice. So for example, I'm creating a user over here called as chain, and I'm creating like a few groups like the dev team, platform, Acme group, and I'll see if I can build a nested hierarchy. So I'll just copy this whole thing over here. I'm just going to paste this around. And if I just happen to run this, you can actually see that we managed to create our user chain, and we managed to create a few groups around here. Now let me create like a few more groups. So this is, okay, so I guess I already created that over here. So next what we can do is we can start to build like a hierarchy. So in this case, let me run this command all over again. And this is where we basically create a hierarchy in this case. We have like added Jane to the dev team. Then we have nested the dev team inside the platform, and platform inside the Acme group. So we have basically built a chain. We have got chain, we have got dev team, we have got platform, and then we have got Acme Corp. Now this is where the magic happens. Let me actually query Jane's direct groups. I'm just going to do this, and maybe let me use JQ over here. So you can actually see this just returns dev team because that's the only group Jane is directly a member of. But when I go ahead and I query Jane, like all the groups that Jane is a part of, this is basically the transitive query. And this is what I can see that she's a part of like the dev team, the platform, and the Acme group. So even though Jane is only a direct member of the dev team, TypeDB's recursive get groups will basically traverse the entire hierarchy in a single query. You don't have to put up any loops in your Lambda code or do any multiple round trips. TypeDB will just handle all of that at the database level. So this is the power of TypeDB. The logic lives in the schema, not in an application code, and this is what makes it so lucrative to kind of start building on. And finally, I guess we have a very nice visual representation of all this. This is a part of the web app experience that's part of this demo itself. And this is where you can see all the users and groups in the sidebar. So if you click on users, you can see Alice, Bob, Charlie, and Jane. If you click on groups, you can see developers, managers, seniors, dev team. So if you click on dev team, you can get to see who are the child members. You can see all the parent groups, including indirect relationships and everything around here. And just remember, like I'm navigating this on localhost 3000. Everything that I have shown you over here is running entirely on LocalStack. There is no AWS account. There are no external TypeDB server. Everything is just pretty much running on my local machine. So I guess with that said, we can jump back to the slide deck. And I can just like end this on some really nice closing notes. So yeah, I guess this was a pretty good thing. And what we have just seen today is just one example, a simple user and group management service, but you can apply this to multiple different use cases. So for example, you can build access control systems. So you can like start modeling up user, group, role hierarchies with transitive permissions. You can start building knowledge graphs. So you can like express your nested structures and inference directly in your schema. You can build org hierarchies, exactly what we have seen today. So you can build like recursive queries that resolve nested group memberships. And the best part about this is the local stack angle, because you can develop and test all of these TypeDB apps entirely locally without requiring to set up any external infrastructure. So the key takeaway over here is that TypeDB pairs really, really well with what local stack is building with this whole local development approach. So you can just take up a data model, you can iterate on that, test your queries, validate everything locally before pushing it back to the production. So I guess someone asked this question, like if I want to take TypeDB for a run during this weekend, what's the best way to do so? I guess what Joshua mentioned is pretty great, but if you want to have like a local experience of doing this whole thing up, definitely try to use LocalStack also to kind of see how this whole thing works out. So this brings us to the end of this session. I guess we definitely went a bit over time, but thanks a lot for sticking around. And I hope this gives you a good idea of how TypeDB and LocalStack work together. You can always connect with me on any of these platforms. And if you have any feedback about the TypeDB extension or with this talk, just drop us a note on this, like on our Slack community. We are always available over there. And you can just scan this QR code and that will directly take you to our Slack community. And with that said, I'm happy to take up any questions. And you can just feel free to drop them in the YouTube live chat or, yeah, just ask away that.
Yes, thank you, Harsh. Now, I would like to just give our chat the round of applause like right now, because folks are very, very interested in what's going on here, and it's very interactive, and we've got questions for you. So without further ado, let's get into them. Yes, VP at Shadow has comments and questions. So his first question is, TypeDB is ready to deploy in one click. Wait, is ready to deploy in one click node in LocalStack?
I would say, yeah, technically deploy, but on your local machine. So if you are trying to do any sort of local dev and testing, you can definitely like just click on a button and it would be directly available for you. LocalStack definitely does not cater to like production use case. So I would definitely suggest you to check out TypeDB's commercial offerings on that front. But if you want to do everything on your local machine and you have got some AWS infrastructure that you want to really pair it up with, like you can definitely take it for a run over there.
Awesome, awesome. And then he's got another question. Are functions in SQL declarative stored procedures? And what is PyLambda?
So I guess these are like AWS Lambda functions. You technically run them directly on the AWS cloud, But with just some crazy engineering effort, we have managed to get them running even on the local machine. So if you want to build and test really against the AWS infrastructure, I know like especially amongst a lot of developers, AWS is like really this old school cloud infrastructure company. But for like really mature development out there, like AWS provides you a lot of those primitives and constructs that really abstract away the pains of cloud development and testing. The cloud infrastructure development. So we facilitate that with LocalStack. You can use LocalStack. You can set up your AWS infrastructure on your local machine, and you can use Lambdas, API gateway, whatever AWS resources you want to use first on your local machine, get everything up and running, and then push it back on the cloud. So it's not a fast API wrapper. I would say like AWS uses something called as firecrackers to spin up like micro VMs on the real cloud. But on our machine, we basically use Docker containers to execute that Lambda code. So you can basically have like a really fast feedback loop over there.
Sweet. Well, actually, so to know you is to know that you've always got something like bubbling in that brain of yours. So as you have like been playing with this integration, what problem are you personally most excited to solve here?
I would say the whole idea of like graph development has been something that has like really suited me for quite some time. I still remember like one of my first internships that I got. It required me to build a graph-based application. This was basically an internal application for a company-based feedback portal. And I know the kind of pain that I went through with this one particular tool that I guess both Joshua and me have named over here in trying to get everything set up. So I definitely kind of recognize some of those pain points. But even like within LocalStack, we have it like really at the forefront of bringing like graph databases up on our emulation layer. And I guess TypeDB is just a fresh entry on that. So yeah, I was really excited at getting like this up and running with LocalStack. So thanks a lot to Joshua and his team, and to also like some of the developers at LocalStack who have facilitated in getting this up and running.
Awesome. Well, thank you so much for your presentation. And thanks everyone for joining. Huge shout out to Joshua and Harsh for sharing their time and knowledge with us. Thank you all for showing up and asking great questions and being a part of the LocalStack community. If you'd like to keep this conversation going, the best place to do that is the LocalStack community Slack. There you can ask questions, share what you're building, and help unblock others and get unblocked. So if you're not there yet, definitely come and join us. We're gonna share the link here, and also we'll drop it in the chat. And if you want to stay connected with the TypeDB community as well, be sure to check out their Discord, where their team and community hang out and dive deeper into graph modeling conversations. And have a great rest of your day and evening, wherever you are in the world. And until next month, stay awesome.